going to conferences all the time is the main driver for progress in your skill set and also your relationship, and basically any professional can become a better professional by attending conferences.
It's not the standard, okay? It's a movie theater, but the visual is great and the sound is great, and I've seen a lot of room and space, and I think it's organized well.
Seeing all the people here today and they're excited about stuff, you can see the energy and the desire to learn and do new things.
And I was positively surprised about the depth, the technical depth of the sessions, and how that makes the tester part of the team.
I think developers do benefit from coming to QA conferences, just the same as testers can benefit from going to dev conferences. You've got to have a broad understanding of what's going on.
It's really inclusive. I would say it's super diverse, people are really open and friendly, and it's really organized.
Conferences are well worthwhile just for the ideas that they spark in people. When people come back to the office, they're full of ideas and they're all energized up.
Oh, hi there. You alright? Yeah, my name is Jorge and I'm an engineer. I'm from Spain and I'm currently living in Bristol, the UK. So you want to listen to that story again, don't you? A story about brave heroes who embark into an epic quest to test their backend services in production while preserving the kingdom peace. Many have been there, most of them never return. But our mighty heroes will find a way. Listen carefully and get off the nos.
Alright, let's do this. Hello everybody, my name is Jorge. Welcome to this presentation about testing in production as part of TestCon 2020. Many thanks to all of you who have tuned in. I hope you're having a great day, and hopefully, if all goes well, you enjoy this presentation and learn something new today. So let's get started. Now, I'm not here to bore you with details about my life. If you want to know more about me, you can drop by my webpage or visit my Twitter profile. Nevertheless, it's worth mentioning that I work as a software engineer for Dyson, just a vacuum cleaner company, and no, I don't have any spare discount codes. Now, this presentation is based on my experience designing and implementing an end-to-end test framework used for testing Dyson backend services in production. This has been quite a challenge, given Dyson supports customers worldwide and has a wide range of connected products with different capabilities each, and now it supports more than 2 million connected products. So we're still learning about it, and this presentation is basically a summary and a compendium of everything that we've learned so far. So yeah, usually I like to start my presentations with a little bit of a poll time, so I will ask the audience to raise your hands if, and I will make you a couple of questions, but obviously given the circumstances, I cannot see you raising your hands, so we're gonna do this instead, right? I'm gonna propose you a couple of questions and I'm gonna let you think about them for a minute. It will make you think and also it will help me introduce the topic. I promise it won't be too long, and if you prefer not to engage your brain, that's alright. You can just skip it, right? So think about this for a minute. Are you having a good day? I hope you are, and if you are not, stick with me, and by the end of the presentation I'm sure you're gonna have a smile. Now I want you to think about what does testing mean to you? When we talk about it, what do you think? What do you think? Do you think on unit tests? Do you think on performance tests, load tests? Maybe you do a lot of manual tests. You are thinking on testing web pages or testing web APIs. What exactly comes to your mind when we talk about testing? Now, have you ever thought there are more testing types than programming languages out there? Well, probably, and each testing type will give you a different picture or a different point of view on how good your services are. So that's quite interesting fact. Think also about testing your services in production, which is what this presentation is all about. Do you think the tests mainly happen before deploying to production, Or is there light after death, or in this case, test after deploying to production? What do you think? Are you testing in production actually? And finally, I noticed that if something goes without saying, why do people still say it? Like, I still don't get it, but it's something to think about, right? But yeah, let's get into topic, right? What is this talk about? So this talk, as I said, is about testing backend services in production. I'm going to talk about what end-to-end tests are and how to implement them. It's mostly answers to frequently asked questions about this kind of test, and it will have also a couple of general recommendations. I'm not going to be too technical on it. And yeah, most of the content is based on my experience implementing this end-to-end test at Dyson, plus some literature and philosophical questions from time to time. I hope you enjoy. What I want you to take from this presentation, my aim is by the end of this presentation, you can reason about why do you need tests in production, what kind of testing is the right level for testing in production, how to build this end-to-end test, what framework to use, how to fight dragons. I actually not going to teach you how to fight real dragons, but we found some problems along the way. So I'm going to explain what those problems were and how did we resolve them. So, Alonso. The first question would be, why do you need testing in production? That's what you might ask me. But first we need to define what is testing in production. What do I mean by testing in production? So my personal definition is to guarantee that your Lambda service or application continues to work consistently after the release or after a deployment. In order to get to that, you'll need to perform some kind of automated or maybe not automated a scheduled test to guarantee that your services keep working as expected after a release, and to make sure that no external factor is negatively affecting the results your services should produce. So this is basically the definition for me about testing in production. Now I want you to look at this picture. I actually found out about this picture a couple of days ago on Twitter. Kudos to Rob. You have his Twitter handle below. Go and follow him for more testing related tweets. But yeah, this picture is about the continuous wall of software development and the continuous cycle. You can appreciate here a common software pipeline. So on the left hand side, we have what happens before the release. So everything of from the problem definition to an idea, to writing the feature, to writing unit tests, and then deploying. This will be the testability wall, and it will present us with risks that we can anticipate and we can work on them. And it's what classically has been known as the development environment. And on the right hand side, we have what happens after the release. So we will be in the operability world, and most of things here will be out of our control, and this is what we classically known as the production environment. As you can appreciate, the figure that it forms is a snake that bites its tail. So we go from a problem definition to a deployment to just go back to another problem definition. So maybe you have to refine a feature, or you need to add more features to the same service, or you need to fix a bug. So it's a continuous process, right? And because of this continuous nature, you will also want to check on your system even after deployment, to check that they are doing fine, to check that there are no errors, even though it has deployed correctly and it has passed all the tests. You want to be checking on them constantly to identify anything that might not be going according to plan, and just go around and go back to the problem definition and fix the bug, right? Now you might ask, why do I need tests in production if I have a health dashboard? I have metrics that are telling me that my application is working fine. Well, are you sure that's good enough? I'm going to show you now an example of a simple function, or a simple serverless function, which is a service that just returns a date, returns a string with the current date, right? So you perform a get operation and it returns the current date as a string. It has unit tests because upon calling this function, you get a string with the current date formatted as a string. It has also its own integration test, so you have checked that actually reaching the API and talking to the API, you get the results you are expecting, which is a string that represents the current date. And you have also manually tested it. So you're going into the API with your app or from the browser, and you have checked that it actually returns you the string. So this is very simple situation, very simple service. There's no new version, so you build the code, you deploy it, and you forget about it. It should always work, and you have some metrics, you have some dashboards, and you are constantly getting 200 OK. So you see that the service is actually answering and is yielding a response to the customer, to the users, right? Until the year 2038. So what happens with the year 2038 is what I'm going to explain right now. So we usually store the dates in variables that are signed 32-bit integers, binary integers. So you can see on the screen now the 32 bits in there. If you have all the bits at 0, this will be the 1st January of 1970. Now the current date is represented by this binary representation, which is the 14th of October 2020. And yeah, this is basically the representation of a date as I said, as a signed 32-bit integer. What happens when we fill up that integer? So when we get to this date, where the first digit is a 0 and then it's followed by a lot of ones, this actually happens on the 19th of January 2038. So because this is counting the number of seconds since the 1st of January 1970, what happens if we add 1 extra second to that date in 2038? It happens that this registry, this variable, becomes 1 followed by a lot of zeros. And remember, this is a signed 32-bit integer. So the first digit, the first bit of this representation will tell you what's the sign of the number that you are trying to represent. And because now we have 1 followed by a lot of zeros, this will mean that the current date, or the number of seconds that have passed in a specific days, is minus 2 million whatever. So there's something going on here, right? That minus whatever, it actually translates to a date on December 1901, which is 1 day after Guillermo Marconi received the first transatlantic radio signal sent 1,700 miles from Cornwall, England to Newfoundland in Canada. So yeah, actually something has gone wrong here, right? So we were actually in 2038, and the second after, we sum 1 second to this registry, and suddenly we are in 1901. So yeah, this demonstrates that no matter how many tests you perform before the release, that the bugs will only show in production, as most bugs, to be honest. If we were probing and testing this production environment constantly as an user, or to the eyes of a user, we will find out about this problem much earlier, and we can quickly act to solve the issue, or maybe not. So yeah, tic-tac. No, don't worry, actually. It won't be the end of the world. Stop running all over your apartment screaming. We already know how to, we already know this problem, and most systems will be patched by then. So no worries for now about this issue, but yeah, you need to worry about your services in production. So now, if you extrapolate this example to your real services, which are much more complex and imply many more moving parts, now it's going to be even harder, and the chance of getting a bug is higher now. So imagine that one of your stateful services become inconsistent and start failing for all the customers. So your customers will make sure that they cannot log in, or they cannot change their profile picture, or they cannot order a chocolate milkshake to take away. And by the time you start looking at the problem, a big part of your customer base is already affected by the problem, and your customer line is on fire. You probably don't want that. So this will be this situation where real angry paying customers will be calling you because what they pay for is not working. Maybe you want to come up with something that actually tells you about the problem before all these real customers notice. In this case, it will be an automated process that, acting as a real user but not being actually a real user, notices the issue and then notifies the team that something is not going well in production, so that you can jump ahead and fix it before any customer actually realize or has time to realize. This is why you need the tests in production, right? This is why you need to constantly be probing your production systems. But maybe you're still not convinced. So let me expand on this. If we talk about, we compare the speed. What happens if you are not testing constantly in production, right? What you want to do when something happens in your production system, you want to fail fast so you can notify fast, so you can get the fix fast, right? You don't want anything wrong to and anything bad to happen in your production environment. If you don't have this kind of automated test in production, right, what you will have is all the customers calling you and telling you that there's something wrong. That's slow because it takes time for the users to realize, and also you will respond slowly to this issue. Whereas if you have these kind of schedule checks on the production system, you will notice probably before any real customer, and you can just jump on and try to fix the issue in production. Another topic will be the losses, like talking about money. Obviously, if you're losing, if you have a problem in production and you're waiting for your customers to realize and to notify you, you are losing time because all the customers are going to be calling you and wasting your time. You are losing money because your services are not working in production, and you will also be paying a lot for support and customers line. So you want to save money on that, right? And last but not least, the company reputation. So it's not the same if you have an issue in production, which surely you're going to have at some point in the future, or maybe you have had it already. Your company reputation is going to be affected because at least one user is going to notice and is going to say that something wasn't working as he expected. But the amount of reputation that you're going to lose if the users know about the issue or realize about the issue before you do is higher than the amount of reputation you're going to lose if you actually are the first one who identifies the issue and then you fix it as soon as possible, so that not that many customers experience the issue in production. Your reputation will be better if you actually are proactive on fixing this kind of things. Now, are you convinced already? I hope you are, because now we are going to explain how or what kind of testing you should be performing in production. So probably most of you know about the testing pyramid, this one, maybe this one or this one, yeah. No matter which testing pyramid you look at, but I want to focus on this one, which will help me explain to get my point straight. So in this testing pyramid, right, at the bottom you have the unit test, then you have integration test, and at the top you have the end-to-end test. Now, the lower you go on the testing pyramid, the easier and faster is to write those tests, and more maintainable are they. So writing unit tests is quite simple, and you'll be testing a small portion of your code, a small portion of a feature, and it will be fast to change it, right, and to maintain it. But the higher up you go through the testing pyramid, the more convoluted are these tests and the harder they are to maintain. But also, the higher you go in the pyramid, the more value the test will deliver. So if you're thinking on unit tests, right, they are going to be testing one very small part of your systems in production, whereas the end-to-end tests are meant to test all system in production as a whole, all your production environment as a whole, that involving tables, databases, queues, all kind of services, and anything that might be happening in your production systems. So those actually drive more value, but as I said, they are more difficult to maintain and more difficult to write. Now, when we talk about this integration test, we want to test a minimum unit after deployment. So integration tests are focused on testing single services in isolation. This is the minimum unit after deployment. This is what you deploy to production: one single service, another service, and you test them in isolation. But when we talk about the end-to-end test, what you want to test is the minimum unit a user sees. So the user doesn't care how many services in production you have. If you have microservices architecture, you have a monolith, a big monolith running in the backend. They care about user intents. They care about user actions, and they care about user journeys. So for example, a user cares about logging in, changing the name of their machine, and logging out. That should work. They don't care how many systems are, or how many services are involved in that, or how many databases. So this is what end-to-end tests focus on. They focus on the big picture from the user perspective. Now, let me introduce you the concept of a smoke test. So the smoke tests are actually this kind of test, automated tests in production. So they allow us to quickly assess the status of an application of a service or a system by running a set of end-to-end tests targeted at checking the most important user flows. So this smoke test should be run after a fresh deploy, so after you deploy a new service or a new feature, and ideally they should be run at regular intervals after that, so you are continuously checking that your systems in production are healthy. And its purpose is to roughly test as much functionality as possible in the shortest amount of time. So these are broader tests, so you want to be testing your whole system in production, as opposed to a regression test in production, which will be very targeted tests to see that you haven't broken any functionality, any feature, or you haven't introduced any new bugs. Now, let's stop talking about theory for a while now and look at a real example, shall we? So I'm going to now explain how this end-to-end test, or how we implemented this end-to-end test functionality in Dyson. We are going to apply this to services, to backend services running in the cloud, HTTP APIs and the like, but that doesn't mean that the same concept I have explained and I'm going to explain now cannot be applied to other areas like the front end. You can still run end-to-end tests in the front end, and you should still be testing your front-end services in production. There are a ton of frameworks out there that will help you implement this kind of concepts, and you can apply the concepts to every software development you do, really. But at the moment, we are going to be focused on this backend API, web API services. So getting into the material, at Dyson we have more than 2 million connected products and users all around the globe. And these users are going to perform a lot of different actions, like link a new product, like start a schedule clean, or maybe turning on the fan. We want to make sure these users can reliably use the functionality and get a satisfactory results and meet the expectations, right? So the best way of ensuring this happens is by becoming the user itself. So we will be putting ourselves in the user's skin and try to do the same single steps a user should do, or a user actually does, to get to the point they want and to get to the expected outcome. And in order to do that, we need to build something like a system or a software. We need to write software that is fast, because it's going to be executed every now and then in production. It needs to be easy to run, because we need it to be automated. We don't want anyone being running the test manually. We need it to be extendable, so every time you write a new feature, you can include it in this end-to-end test, and it's right away tested in production. And the main point is it needs to be behavior focused. So it's all about user behavior, and we want to replicate that user behavior to make sure that if an end-to-end test passes, we are 100% sure that a user can do the same actions and get satisfactory results. And if an end-to-end test fails, chances are that the user intent or the user journey is going to fail too. So one-to-one, right? How can we define this kind of end-to-end test? So basically you need to be behavior focused, and you need to define what's the behavior of your user, of your virtual user. So we are going to have a starting point, a configuration, or a given user. Then that given user is going to perform a sequence of actions, and finally it's going to expect an outcome, right? That we are going to check that is true. Now, how does that translate to a real scenario? Probably maybe at Dyson. So at Dyson you can turn that into this scenario. So you have given an existing user with this configuration, that's the starting point. Then the user logs in, then the user changes the robot name to RobotMob 9000. Those are the user actions, and finally the expected outcome, which is the robot name has changed to RobotMob 9000. Now down there you have a link to a web page with one of the best robot vacuum names that you can put if you want to have fun at home. But let's just skip that, and let's get over how it works really in Dyson production environment. So this is the real scenario, how it really looks for Dyson. We have on one side we have the cloud and the cloud services, and on the other side we have the user, which are going to be using the app, the smartphone app, to talk to their products through the cloud. So all our services are living in the cloud, and those are the services we care about and we want to test in this testing in production session. But the thing is, you don't want someone to be testing this manually and having to log in the smartphone app every 5 minutes, and neither you want the robot dancing around the office while executing the test every now and then. So as we are only interested in what happens in the cloud, we're gonna mock and we're gonna put into software the user's behavior and the machine behavior. So this is how the end-to-end test framework works. We have a software program that mocks what the user and what the products are gonna be doing to interact with the cloud. In this case, they are interacting using HTTP web APIs. So we're gonna have these users encoded as code, and they're gonna be calling our services in production and verifying that they can perform the actions that we're gonna tell them to do. So how we transform that, how we translate that into code? Well, we choose to use the Node.js JavaScript runtime, and then we use a combination of a library called Cucumber.js, which is a library that helps you define in these behavior scenarios. Then we also use the request and assert library. So the request library is used to make HTTP calls to the cloud services, and the assert library is to assert that what we get back from the cloud services is actually what we are expecting. So the last bit of that scenario, which is checking the expectations. Now, what we're gonna have is a lot of singular steps inside this framework that perform little things and talking to APIs and the data transformation, and then we are gonna be putting these little steps, we're gonna group them together into a user journey or a scenario, as we have seen before. So you will have the little steps will be given an existing user with this configuration. The user logs in. Those are two steps, right? We call them steps, and then you put steps together to build a bigger scenario, which will be this one. And you can have as many scenarios as you want. This will be a collection of scenarios, which transform to a collection of end-to-end tests in production. Now, these tests are really a good indicator of how your services in production are doing, just because they try to be as close as possible as what the user will be doing, and we'll be testing all services. And we don't care about how healthy are our services. We care how healthy is the system, the entire system in itself, and if a user is able to perform the user journey successfully or not. But remember, because we are running this in production, it might change the state of your system and it might end up affecting real users if you are not careful. Remember, we are testing these services in production, so at the same time, the real users are using the same services and using the same databases. So you need to be careful with what you touch. As a good friend of mine used to say, not touching, not touching. Be very careful with it. Now we're going to explain a couple of problems that we found along the way using this be careful as a base. So if your tests are too close to the real users and to the real actions, you might get into trouble. So some examples of that are if you run a lot of end-to-end tests against your production systems, against your web APIs, for example, you might experience a higher latency because you are hitting your web API more often than it was expected to. Then also, if you have a database in the backend, right, you might be reaching throttling limits or some other kind of limits, read-write limits, any kind of limits, because now you're going to have not only your real users, not only your expected load, but now you're going to have even more load because you are running these tests in productions, right? So need to be careful about that. And there's some ways of solving this. The main way is basically spacing out these end-to-end tests. So we said before that ideally you should be running these end-to-end tests every 5 minutes, every 10 minutes after a deployment, like on a scheduled basis. And the benefit of that is that the more often you run the test, the faster you're going to not notice about the issues. So if you, for example, run the test every half an hour, it might take up to half an hour for you to realize, so for the test to notify you that something is not right in production. So you want to run them as often as possible, but you ought to strike a balance, because if you run them often, then they are going to be hitting your APIs often, and you get higher latency, you get noise. So yeah, you ought to strike a balance. Now, another problem we found is actually running these end-to-end tests will skew our metrics, right? So it happened one time that we had these metrics about our service, and we were reaching around, let's say, 200 requests per second, and it was stable over the days. But at some point, that metric dropped from 200 to 100, so a 50% drop, and we were quite concerned about it, and we were asking ourselves what happened. The whole team was alarmed. Because something wasn't going as expected, and maybe users stopped using Dyson products, or what was happening. We later found out that the tests weren't running. So basically, the tests were also generating those metrics. So our services were deployed in production. So they didn't know about any testing going on. They just care about users, virtual users or real users making calls to them. So they were logging all the metrics. So usually we will get 200 requests per second, but when the test stopped running for another reason, all the metrics dropped to 100. So basically, this end-to-end test in production will be skewing your metrics. Like, for example, the number of user interaction with your system, or the API usage, or you might get a different error count and you might be concerned, but maybe it's only the test. So it's difficult. And you will also get mixed logs. So if you look at your logs in production, some will be logs from real users interacting with your system, and some other logs will be the end-to-end test interacting with your system. Maybe you're not that interested on the end-to-end test logs, but you are mostly interested on the user logs. So you need to find a way of decoupling them so you can actually focus on the things that matter when you are debugging an issue. You could use a combination of these three strategies to try and filter out the metrics and try to filter out the logs. You could use a correlation ID that starts with a predefined prefix. So for example, FFFFF. And you put that on every request that goes from your end-to-end test to the cloud, and later on you'll be able to filter by that correlation ID. You could also change the user agent or add a custom HTTP header, because these are HTTP requests to a backend API. You can modify these strings to be whatever you want, and then you can filter them out. So those are three solutions or three strategies to try not to mix the metrics and the logs between real users and your end-to-end tests are running in production. Now you might be quite convinced now about running your end-to-end tests in production. So all cool, or maybe you have them already and you're saying, oh, this is going great, they pass, our systems are flawless, right? What about all the fake data they have generated over the days? So it happened to us also that we weren't cleaning after ourselves, so the end-to-end tests were generating fake data every time they run. So we have the end-to-end test running for a couple of months, and they were constantly generating fake data, and this fake data was being stored in the table, right? So we have this pagination in the table, and our services didn't expect the pagination to go over 10 pages. So they had a limit of 10 pages, because you have to set a limit at some point. You cannot say, okay, retrieve unlimited pages. So the limit for that service was retrieving 10 pages, and that was alright for real users. But the moment we started polluting the database, right, the number of records went up like crazy, and it went past 10 pages. So there was a moment where the users, or a single user, was trying to make a query to a database to get maybe the robot name, and the database or the service said, oh, you are not in the database, because there were more than 10 pages, and the results to that specific user was far beyond that 10 pages, which were just trash data generated by the end-to-end test. So definitely you need to clean as much as possible after each test, and the objective here is to leave the system, to leave the service as you found it, to leave the databases as you found it, to leave all the state of the different services as they were before, as if the end-to-end tests never ran there. That also helps starting the end-to-end test from a clean state, avoiding false negative, and each test is independent, and also you make them idempotent. So whenever you run a test, because if it's going to clean after itself, you can run it again and again and again and again, and it should always produce the same output because you are cleaning after yourself, so it's going to start brand new. So that's actually a good thing to have. And it will be avoiding cluttering your production databases. It avoids exhausting all the kind of limited resources, and also avoids making real data more difficult to retrieve, because it won't be generating that much noise because you are cleaning after yourself. So cleanup is an important thing here. Now we are getting close to the end of the presentation. You might say, wow, all of this is interesting. I have a lot of questions and I'm going to ask Jorge about them. We're going to have a 5 minutes live Q&A session after this presentation, and also you could contact me after that Q&A session. We're going to have, like, I think 20 minutes to discuss about anything you might want to talk about. But I want to get ahead of that and try to answer a couple of common questions that you might have in your minds now. So one of them is, can a system failure or a bug go unnoticed to your end-to-end test? The short answer is yes. But most of the time it will be alright because you are acting as a real user. So if your end-to-end tests are passing, that means that a real user performing the same steps as your end-to-end test, we should be performing the same steps as your user does. If both are passing, then chances are that the user can actually get a successful response to their user journey. But of course, end-to-end tests are no silver bullets. So it will mean that at least you are not completely screwed. And you need to complement this end-to-end test in production with other tools like active monitoring. You need to have metrics, your dashboard, you need to do some kind of manual testing, you are going to do regression testing. So yeah, again, end-to-end tests are no silver bullet. The next question is, well, by the nature of this end-to-end test, they span across multiple services, and it will affect different teams. So who really is responsible for maintaining this end-to-end test, and how do teams collaborate to write them? At Dyson, we assign user journeys, or these scenarios. We assign a couple of them to different teams. So whenever those scenarios will fail in production, they will notify that team, and that team will look into that issue in production. If it's related to their services, they're going to jump and try to fix it. And if it's related to a service from another team, they're going to notify the other team, giving them all the information to help them debug the issue and find the problem. So it's a joint effort. And in terms of how the teams collaborate to write them, everyone is welcome to contribute to the end-to-end test. And because they are focused on the behavior rather than on the code, as long as you have this single step that you can put together, and as you can put as many steps as you want and write your own scenario in plain English, you will need to know how to go. So actually, everyone who wants to contribute to the end-to-end test can write an end-to-end test. Now, another question is, how do end-to-end tests compare to dark code canary deployments? Do you need both? Yes, the answer is yes, you need both. They are completely different things, and they serve completely different objectives. Basically they are complementary. So both are useful when you are deploying services to production. I'm not gonna dwell on it. And the final question will be, how do you avoid your end-to-end test become fragile? Because no engineer wants their test to be flaky or to be fragile. So you need to make sure that the end-to-end test represent the user interaction as closely as possible, and this end-to-end test should be clean after themselves and clearly define also which tests are critical to your infrastructure, to your production infrastructure, and which are not critical, and also make sure they represent, as I said, exactly and as closely as possible the user intents and the user expectations. Now, a quick recap on the whole presentation. Testing in production is good and necessary. I hope you realize that. Think like a user, act like a user. Cucumber.js as a library for Node.js for implementing this kind of behavior-based tests is a good start. Now you also want to think about your system capacity to avoid clogging up databases or increasing the latency of your production systems or your production APIs. You also want to map your test intents to differentiate them from real user interactions. Clear your test data and reset connections and status after each test, so clean after yourself. Yeah, that's basically it. Now, please use the comment section. I don't know where it's going to be, like down there or on the sides, to ask me any question in the next 5 minutes. You could follow me on Twitter, and I hope you enjoy the rest of the conference. Thanks for listening to my talk. I hope you have learned something new today. And are you brave enough to test your services in production? I hope you are. Thank you very much. Great, thank you. Wow, so many questions here. Thank you for raising them. I'll try to answer as many questions as I can fit in this time slot. But if I don't answer yours, you can also join the Zoom room, and I'll be there for just another 20 minutes. So yeah, let's look at the questions. So yeah, the most bold question is any tips? It's from Anonymous. Any tips for testing payment-related tests in production? Wow, yeah, that's a real complex situation. I guess it depends on the third-party integrations that you might have with other systems, maybe other banks. And I also assume, or I guess, that you can afford to be constantly making transactions here and there with real money. I don't know the very details of your system really, but I think you could have some real accounts with real money, maybe just a couple of euros, and only use them for testing. Another thing I'm thinking now is maybe there are fees involved. Is that right? So that could be a problem, and it will become much more difficult to perform this testing in production. I guess the answer here is if your actions cannot be really automated because you need, you need to do real payments or real transactions. I guess you'll need to look at other ways of testing these systems. For example, you will want to have some manual tests that you execute from time to time to make sure that the payments are going through, or maybe monitoring the third-party services you work with to look for an increased error rate in transactions, in user transactions. So that will be, you won't be able to make transactions from an automated point of view because of how the system is built. But surely you can still monitor what's happening in production and try to act as fast as possible if something happens. Next question will be any challenges resetting test data to initial state on production? Yes, actually, there's some challenges. So if you're interacting with databases, you probably need to have some way of deleting those records from the databases, and that will imply that your API will need to implement a delete method, so you can call it and delete the stuff the tests have been creating before. As some of our APIs didn't have this delete API endpoints because we don't want anyone accidentally hitting them and deleting production data. We actually had to, every now and then, like every 2 weeks or every month, we'll look at the production databases and perform an action to clean all the test data that were previously identified by using a test email or using a test prefix on the correlation ID, as I mentioned, or anything like that, to identify the records we want to remove, and we will manually remove them from production databases from time to time. Maybe we have a couple of seconds for another question. Do you also run these end-to-end tests in your staging environments or only in production? Yeah, that's a good question. I actually was expecting this one. Most of the time, we want the staging environment, if you have one, to be as close as to a production environment as possible. It also makes sense to run these production tests again against this environment. This will mean that you can catch the bugs and issues that new feature might be generating before even having those in production, which always helps, right? The only downside of that is that your staging environment, you won't be able to, you won't have the same load of usage that you have in production. So it's still not quite like production in terms of load, but it's a good idea to test your system as a whole in a staging environment if you can. So that's it. I don't have any more time to answer the rest of the questions. Thank you very much for listening to my talk. And yeah, if you still have more questions, join me on the Zoom channel. Thank you very much and enjoy the rest of the day.